Welcome to the very first lesson of our geometry unit, lesson 73, and we're going to work on area and perimeter of quadrilaterals. So in this lesson, here's what I'm going to do, and I want you to pay attention to these steps. 1, watch how I identify the base and height in my quadrilaterals. That's going to be really important to find those two dimensions in order to find area especially. And then watch how I accurately classify quadrilaterals. I'm going to use a number of questions that will talk about parallel lines and right angles to see if I have any special quadrilaterals. And then how I accurately calculate the area of quadrilaterals using dimensions and formula. Once I get some practice in, it'll be your turn to practice and show what you know from this lesson. So you got yourself a four-sided shape. It's a quadrilateral. But how do you know if it's a special quadrilateral? How do we recognize it? Well, we're going to learn to recognize these special quadrilaterals by asking ourselves 3 questions about the lines of the quadrilateral. So let's start and look at question number 1. How many pairs of parallel lines do you see? So these are lines that are opposite each other that are always the same distance apart. And there are 3 possible answers: 0, 1, or 2 sets of parallel lines, 2 pairs. So if you have a shape with 4 sides and nothing is parallel, well, you just got yourself a quadrilateral, regular 4-sided shape. If it has 1 set of parallel lines like this little guy, and you have yourselves a trapezoid. Look at the top and the bottom line. In this case, for a trapezoid, we call those bases, base 1 and base 2. They are the ones that are parallel to each other. They're always the same distance apart. And that's how we actually can identify base 1 and base 2. Now, if you have 2 sets of parallel lines like this little guy, then you have a parallelogram. That's where it gets its name. Let's look at our second question. How many congruent sides do you see? How many equal sides? So again, we have our 3 different sets of families. And in the first family with no parallel lines, if you have 2 sets of equal sides, then you might have a kite. And notice with the kite, the 2 lines on the top above the eyes are equal, and the 2 lines on the bottom next to the rosy little cheeks are also equal. Let's look at the trapezoid. And there are 2 answers. You can have 1 set of equal sides, and we call this an isosceles trapezoid. And with the isosceles trapezoid, it's not the bases that are equal, but it's the 2 sides on the outer ends. Those would be equal to each other. Now, if you don't have any sides that are equal, then you just got yourself a regular old trapezoid. Easy enough to recognize. It has parallel lines, and a base 1 and base 2, you can identify it. Now, let's look at our third family, the parallelogram, where we had 2 sets of parallel lines. Now, it's possible that you have 2 sets of equal sides, and you got yourself a parallelogram. That's what parallelograms have, 2 sets of equal sides on the opposite sides. But you could have a parallelogram where all the sides are equal, and we call this the rhombus. It means every single side has the exact same length. And typically we can see a rhombus that looks like this, like a little square just tilted over. And we have one more special rhombus, the square. Both of these shapes have all equal sides. Let's look at question number 3. Do you have perpendicular lines? These are lines that make right angles, so you can recognize them as one that's going straight up and down and the other one is going horizontal. They make a perfect 90-degree angle. So here are the 2 possibilities. We're going to look at 2 sets of families. We're going to look at the trapezoid family and the parallelogram family. Now, with trapezoids, you might have 1 parallel line, 1 set, or you'll have none. So if you see 1 set of parallel lines like this little guy, you can see it makes a nice right angle in that bottom right corner. We call this a right trapezoid because it has a right angle. Makes sense. Now, if it doesn't have any right angles, again, it's just a trapezoid. Let's look at parallelograms. If you have no perpendicular lines, well, you just got yourself a regular parallelogram. But it's possible that you have all 4 sides have perpendicular lines. You see 4 right angles. You see them everywhere. Well, in that case, you have a rectangle because you have all right angles. That's what makes it a rectangle. I can see 4 right angles in it. Now, there is a very, very special rectangle. We've seen them before, our square. Our square also has 4 right angles. But remember, a square, not only is it in the rectangle family because it has 4 right angles, but it's also a rhombus because it has all 4 equal sides. And that's it, Math Marbles. These are the 3 questions you can ask yourself. So if you want to identify special quadrilaterals, ask yourself, do you see any parallel lines? Do you see any congruent lines? And do you see any perpendicular lines? Let's jump into our first problem. This figure is most likely or most often called a what? So the first question I'm going to ask myself is, and just looking at our picture, how many pairs of parallel lines do we have? I see 2 sets. These 2 are parallel. They are never going to meet. And these 2 are parallel. Kind of like when I'm looking across the street, the other side of the street is parallel. They're both same size going in the same direction. So here I have 2 sets of parallel lines. That means I know it is absolutely not a trapezoid. So it is definitely a parallelogram. So let's try and distinguish if it's a rhombus or not. So for a rhombus, my question would be, okay, so that's my second question. Are all the sides equal? And my answer to this is no, all sides are not equal, so I know it is not a rhombus. And now I'm going to ask, how do I know if it could be a rectangle? A rectangle is a parallelogram, so my question is going to be, and my answer to that is no, I do not have 4 right angles, so it cannot be a rectangle. So there we go. I would absolutely say this is a parallelogram because it has 2 sets of parallel lines. It cannot be a rhombus because it does not have 4 equal sides, so no to rhombus. It cannot be a rectangle because it doesn't have right angles. And it can't be a trapezoid because it has 2 parallel lines, not 1. Hit pause and jot this down in your notes. Next 2 are going to go super quick. We're going to find the area and perimeter for both parallelograms. So for area, we just want our base and height. So looking at my first one, I just want the base and the height. So area is equal to 12 times 7. So that means my area is equal to 84. Just always double checking. So we have this one in there. We would substitute, we would find the same thing. For perimeter, we're doing 2 times the length and our width, the side parts. So I'm doing 2 times 12 plus this side. This time I want 11.5. Like, why am I doing that? Because if I were to write all the sides in here, you would see I have this number twice and I have this number twice. So rather than adding 4 numbers, I'm just condensing down my work. So let's do what's in parentheses first. And I'm adding these and you would get 23.5. So 23.5. And 2 times 23.5 gives us 47. We'll do the same thing with the next one. This one has a lot of fractional numbers. So area is, let's look at the numbers I want. I want this base. I want this height. 2.5 times 5 and 1/4. I'm going to change these into decimals so I can work with my calculator. So 2.5 times 5.25. So 2.5 times 5.25 25 gives me 131.25 inches squared. I forgot my other units, so let me make sure I put those in. Okay, there we go. And let's do our perimeter. So I want 2 times 7 2/3 plus 2 1/2. So this one's going to be a little trickier. I can't change 2/3. Just to practice again, change my 2/3 and 1/2 into the same denominators. So remember, I can do 2/3 plus 1/2, and I'm going to multiply, multiply, multiply. So I'm going to multiply first. My denominator is going to be 6. 3 times 1 is 3. 2 times 2 is 4. So I'm going to get 7 6. Okay, so just so you can see, all I did was change 2/3 to 4 6 and 1/2 to 3 6. So together they would make 9 and 7 6, or 10 and 1 6. Okay, and now I'm just going to do 2 times 10 and 1 6, and that will give me 20 and 2 6 as a perimeter inches, and I can change that to 20 and 1/3 inches. Whew. This one was a lot of work, Math Marbles, quite a bit. So take a moment so you can jot this one down in your notes. Let me put a line in there so you can see my perimeter versus my area. And again, if you need more practice adding and subtracting with fractions, go back to some of our earlier videos. I will see you in the next lesson, Math Marbles. Bye!